We were told space is calm, vast, even, silent, a dark ocean filled with distant stars. But the space around us is not normal. It is thinner than it should be, much thinner. In the 1970s, astronomers noticed something strange. Measurements of interstellar gas near the Sun were dramatically lower than expected, not slightly lower. Depleted? At first, they suspected error. Telescopes were recalibrated. Models were adjusted. The anomaly remained. Then something else appeared, a faint glow. From every direction, X-ray telescopes detected hot plasma surrounding our solar system. Extremely thin, nearly 1 million degrees Kelvin. Cold gas had been pushed away, replaced by heat. When scientists mapped the region, they found a cavity almost 300 light-years wide. They called it the local bubble, and we are inside it. The obvious question followed. What could carve a structure this large? The answer points to violence. Supernovae, massive stars, ending their lives in catastrophic explosions. Over the last 10 to 15 million years, a nearby group of giant stars collapsed one by one. Each explosion released a shock wave. Each shock wave pushed interstellar gas outward. One supernova can clear space. Multiple supernovae can reshape a region hundreds of light-years across. Recent studies suggest between 10 and 20 explosions form the local bubble. This is not speculation. Radioactive iron-60, a signature of supernovae, has been found in deep-sea sediments on Earth, dated to the same period. At least one explosion may have occurred within 100 light-years, astronomically close. We are not near the blast. We are inside. The aftermath, the local bubble, is not frozen in time. It is still expanding, slowly. Its outer shell contains denser gas. That compression may have triggered new star formation, stellar death leading to stellar birth. Our solar system did not create this structure. We drifted into it as we orbit the Milky Way. For millions of years, Earth has traveled through a region shaped by ancient explosions. Does it affect us? Possibly. Nearby supernovae can increase cosmic ray flux. Cosmic radiation interacts with our atmosphere. Some scientists suggest subtle climatic effects. The geological record contains traces of supernova material. Not extinction, but evidence. The most unsettling part is not danger. It is perspective. We are not floating. In ordinary interstellar space, we exist inside a scar left by multiple stellar deaths. The calm around us is not default. It is aftermath, and the bubble is still expanding. There is one more layer most people miss. The local bubble is not perfectly empty. It is structured. Filaments, fragments, thin magnetic walls. Recent 3D maps from the Gaia mission show that our entire stellar neighborhood sits along the inner surface of this expanding shell. Young stars are forming exactly along its boundary, as if the explosion did not just destroy, it reorganized. Compression from ancient shock waves may have triggered new generations of stars, including the region that would later give birth to our sun. This means our solar system may indirectly owe its existence to those explosions. Not random, causal. There is another hypothesis. Some researchers suggest that as the bubble expands, it interacts with surrounding interstellar clouds. That interaction creates turbulence, magnetic pressure, instabilities. The region around us is dynamic, not passive. We are moving through a structured cavity, shaped by past violence and still evolving today. The silence we imagine in space is not silence, it is aftermath. If you zoom out far enough, the local bubble is just one structure inside a network of other bubbles, interconnected, layered, stacked across the galaxy. Space is not empty, it is sculpted, and we are inside the sculpture. If this changes how you see the sky, subscribe, because the universe is not what it first appears to be.